Okay, we can start. So first of all, thanks for having me. I'm Flavio. I'm originally from the Frankfurt Flutter Meetup, which matches Frankfurt on mine. So yo, it worked out for me pretty well. A little bit about me. That's me. You can find me on Twitter. You can talk to me on Twitter. It's not very exciting what I post on Twitter because I don't post anything on Twitter. I'm most there to look at other people and feel like I've, gaining information out of that. So you can write me there, or you can write me on my email. I'm working for this company called CodeCentric, and I saw on Vince's slide that CodeCentric was also on the first meetup you guys had here. So hey, full circle. Just before I start, sometimes I tend to speak a little bit fast. So if you guys think this is too fast or anything, just do a signal. Like if you feel you're in a Macklemore versus Eminem concert kind of thing, just look at me, make eye contact, and go like. Just don't be too excited like this, because I think you're enjoying it, right? So just chill. All right. So I hope no one got misguided and thinking real-time Flutter, what we're going to do here. So first of all, let's explain. We're going to define the problem that we're trying to deal with, and then I'm going to show real-time one-way communications, and these is polling, long polling, and server send events. Don't worry if you don't know what it is. That's exactly what I'm here for. And then the two-way communications with Websockets and WebRTC. The first time I did this presentation, I was focusing solely on WebSocket, so I extended a little bit. And it's because of that and because of time constraints, it became a little bit like an overview generally. So we're not going too deep on any of these topics. I mean, probably you can have a talk on any of these topics. It takes an hour by itself. But if you have any questions, just feel free to raise your hand and we can answer them right away. And the worst thing that can happen is I'll just say, sorry, I have to move on or else I'm not going to finish this. So feel free to just raise your hand and ask away. So first is the problem. And I have to say it's the problem in this context. Right? The whole web was initially planned out, and the whole web system, the ecosystem and the web apps that were created around this client-server model. Right? This idea of I'm going to ask something and I'm going to get something back. This is just a one-sided thing, and it always came from the site itself. The server was a passive entity, which did nothing else than just answer something that got asked from him. So to get an analogy of this and to make this presentation a little bit more interesting, especially if you have 2 or more beers, I found this analogy here, and you can take a look at this handsome and well-drawn character there. And imagine that that's our client, and he's talking to the server, which is aptly named server. I wasn't very inspired, sorry. So he just asks, hey, I like the index HTML, right? So he gets that from the server. And he sees, oh, wait, I still might need some other things like JS files and CSS and images and everything. So he makes one request for each of them too. And he gets those. But if you actually ask for the server, hey, could you give me data when it comes in? So like, hey, I don't want to ask again. Just say when it's something there. Nothing happens, right? The server doesn't know how to deal with it. So looking at a little bit more in a diagrammy kind of way here, the idea is we make a request, and this is HTTP request, which uses TCP under it. So you would have a handshake. You do a get to get the data, and eventually you would finish this exchange of data. The other colors here would be for the other stuff that I asked, so images and JS files and everything like this. I did one each color, and that would mean all the stuff which is in blue would also have to be made for the red and for the green and everything. So there's a certain work that it has to be done on each of these requests, right? So this was not optimal, especially if you want something which is close to the theme of this talk, which is real data. This is not going to work for you. So people start making ways of using this, but making it seems like it's real time. And the first solution, and I try to put them in kind of like a growing order of complexity, and I would say historically, but I cannot prove that, so don't hold it against me. The first one was polling. And polling, again, I found a cool analogy of this one. And it's just being like that annoying kid on the back seat. You know, I was one of them, you probably too, which is just asking your parents, like, are we there yet? Right? So the server is just gonna, give a thread and say, hey, Junior, you know what to do, right? So what happens is, Junior goes there and asks like, hey, any data yet? Server answers no. So he waits a little bit, and then he asks again, no, still no. Then he hates again, and that happens and happens and happens and happens, and it still happens, right? Until the server gets annoyed, which doesn't happen anymore.
Did you draw this yourself?
Yeah, I did.
Awesome.
I got a new iPad with a pencil, and I'm like going crazy everywhere and drawing everything. Thanks. All right. So here's the idea. You just define an interval that you want to wait, and you just ask, right? So this works, and it makes it feel like you're getting data from the server whenever there's something there. But if we put this in a graphical manner, which everyone can understand, you see that is not the case, right? You can do a request, and then it responds with 204, which means no data. But eventually, when there is data, which is this line coming in here, you would get a 200 and the data, and then you wait again. The problem is exactly this wait, right? You can wait, and there's another data that came in while you're waiting, and then it's going to have to, the delay has to be done until you get this data, so it's not real time anymore. It's better than before, but it's not real time. You can use some solutions there. I've seen some people talking about making some, Markov chain-oriented delay times and starting small and making bigger every time you don't get something back. But let's keep on the easy case, and that's the problem we can see when that happens. So the solution for this was to use something which is called long polling. And long polling is about the same thing, but we make a request, and the server takes a little bit of the control there. It holds your request for a while until data is there or a timeout occurs, and then when something is there, he gives you back like the data, right away, or until this timeout happens. And when you get that, the timeout or the data, you immediately make another request, and the server holds that again. So these keep going. This is better. But we have a limitation here, and it is you can do about 6 of those parallel. This is a HTTP limitation, and I'm going to make these slides available afterwards. Vince is going to put with the video. But basically, everything I'm saying right now, I also wrote it. That's why I keep looking at it. But I put the links also to references of these things if you want to read a little bit more into it and everything. But this is a limitation we have for HTTP. It's about 6 connections parallel per browser and not per tab or anything like that. So even if you try to cheat and open more tabs, this is not going to help. And even for older browsers, which I guess none of us are using anymore, it's about 2 only. So you have a limitation on the amount of stuff you can do with this. Right? Because we're in a Flutter meetup, I thought, okay, I can keep talking about these things, but I have to show a little bit of what's that with Flutter. So I went out and looked for a couple of libraries there are in PubSpec, in the pub repository, and basically what you need to make polling or long polling work is just an HTTP request. That and Flutter delivers out of the box the rest of the stuff you need to make this work. So I found 3 of them, and again, there are more. These are the 3 I found, and I listed with their versions and also the date of the last commit. Because I think versions don't tell you a lot about. Like I'm pretty picky when I'm working on my projects. They're never 1.0. I'm never going to be done with them. So I think some guy says, hey, mine is 0.12, but some guy is saying, oh, mine is 3. So if you go around that, you're probably going to get 3, but maybe it's not that good. So, don't judge a repo by its number, I would say. So let's take the first one, the HTTP one, which is, I think, is one of the most used or had the most downloads there. And you can see this is pretty simple. You just have a method there, which I call fetch post, which take posts, and it does a HTTP request. And you put this inside a future, and here I listed, you can use like when complete, which will receive something, whatever. It might be an error or a success or a data, and you have to handle it. You can use then, which the same, you can use an on error inside, or you can, and this is the best, like the way you should do it, which is you use then for the case you have data, and on error or catch error for the case you don't get or you get an error. But basically what you should do here is then, if it's long polling or if it's long polling, as soon as you get something, you make the request again, right? You just wait for it again, and the future is going to be there again. If it's normal polling, just do the timer, and then ask again when the timers went out. That's it. This is pretty simple to implement. Basically, the work here, it's just two-liners, I would say. Of course, your logic may change from mine, but there's not a lot to do in the server. It's standard HTTP requests. There's no big thing happening here. So we cannot leave like this. We have to complicate it a little bit because we're programmers and we like complexity and like to throw in the face of people that we can deal with that. At least I do. So server sent events is the next one that I'm going to talk about. So server sent events is quite interesting because, to be honest, I didn't know when I first started looking to it. I was like, oh, this is a good idea. Why didn't I know about it? The idea here is you do it's a pub sub kind of thing, right? You talk to the server and say, hey, whenever there's something published in this topic, I'd like to know about it. The server responds to you with a 200 saying like, okay, I got it. And every time there's something there, it's going to send you this data. So you're just listening to a stream of data that might come from the server. This tends to work quite well, and I'm gonna play devil's advocate here during this talk, and some cases where you think you might be wanting to use WebSockets and you actually should be using this instead. But this, again, this is the same problem as before. This is there's the limitation of 6 connections at the same time, which might be a problem, but again, it might not be. For example, for a simple chat application, it's not a problem, right? You can have one on your chat you're into, and then just when you close the chat, you maybe close that, or I don't know. So you just have to analyze on a base-to-base situation. So is SSE used? The best thing when I want to know and answer this question is I go to caniuse.com. I don't know if you guys know this. So if you don't know this, it blew my mind first time I saw this back in 2000, I guess. The site was very, 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 very small back then. Now it contains a lot of stuff. But basically, what it shows is you Google for a certain technology, web technology that you're looking for, CSS, HTML5, or JavaScript, and you get a list kind of like this, where it shows you the browsers and its support. So green, it means it's fully supported. Red, it's not supported at all. And if it's yellow, it means partially supported, and it's also explained why partially. Might be they implement something different, or they thought it's not worth implementing. On the corner here, you can say usually a global, and also maybe if you put your country, it will show on your country how much people use it. I guess because of SAP, there's a lot of people that use Internet Explorer here in Germany still. So you always see the Internet Explorer going a little bit up there. And I mean, I had to support Internet Explorer 6 and 5 for a while there. It was not fun. So here you can see you have a pretty good support for server-sent events. And of course here we're usually looking at web context, but I think this reflects quite well to mobile world. Usually if you have something implemented for web, there's a good chance you have a good support for mobile too. Again, don't take my word for it, check it, see if that's the case, but I checked it, so it should be the case. So, Flutter. I only found this one library there. So I would characterize as support is still very shy, right? It's not great, it doesn't have a lot of people doing that, but what I have to say for it is this event source library there, It implements the API, which is defined by Mozilla, and it's extremely easy to use. So it's basically, you don't need anything else more than that. So I guess either people didn't look into it very much, because like I said, I didn't know a service and event when I first looked at it. Or I didn't look enough on the website and didn't find anything else. It might be that I didn't put a lot of effort into it. And if that's the case, and you know of a library, come talk to me later. Don't shame me right now, but just come to talk to me later, and I can put something else on this slide here. But the idea is, you will have an object called an event source, which you can connect to a certain path on your website, on your server, and that's a sink, right? That's a listener where you listen to a stream of events. And in this case, you would get an event, and we're just printing stuff out here, but that's just what you need. Like a lot of the other stuff that I'm going to talk, like SSE now, and all the other Websocket and WebRTC, the problem usually is not on the client side, but on the server side. Like that's where most of the logic and stuff you have to think about is. So SSE you see on the front end, there's not a lot there. You're just subscribing to something that you're interested in, right? So for the server side, I choose one example. Sorry, it's Java. And it's Java because, and I was talking to Vince before, like he's talked to me in a deeper sense, because I tried doing stuff with Dart on the back end and I didn't like it, or let's say it didn't work as well as I would expect, but I always blamed because of my knowledge of Dart as a back-end language, right? I work on my day-to-day with Java, so this feels familiar. I get running quite faster. So I like this Javelin framework. It's a micro framework, so you write stuff more reactive, more on a stream kind of way. And the idea here is I have a queue, which are clients, let's say. And the first thing I define is just saying, hey, on the app, if someone connects on this /SSE, I want you to handle that as being an SSE connections. And it knows that it's going to be a client. You can add this to this queue, and then you can use the clients to send events to it, and also do a callback for it in the case of when it's closed, right? So in the case of it's closed, we just simply remove the client out of this list. This is a pretty simple example, of course. But we simulate like messages coming in this while loop here, where we simply just wait 1 second and then we ping all our clients. That's it. That's what the server will do. Of course, you just change your logic for what you need and send events when you actually need. Yeah?
How is it handled on the protocol level? Is there a TCP connection permanently open?
It's HTTP the whole time, and yeah, actually yes, there's some TCP connection.
Has to handle an open TCP connection per client.
Yes, but the same thing as polling or long polling would do, so you don't have a lot of, I mean, this is one thing that I found is these things are kind of solved. The protocol takes care of a lot of the stuff like reconnections and stuff like that, which is not the case for stuff we're going to talk later on, like WebSockets and everything, which can be very complicated. But yes, you would have to, I mean, none of these is magic, right? It's not like you send something and the guy, the server knows where to find you anytime. It's not the NSA, so it needs to be in some kind of connection with you. I hope NSA is not looking at this video. Alright, so any questions up to this point? This was the one-way part, so we're going to start with WebSockets after this. So I would call this the halftime. I know I've been a little bit faster. I said it was going to be an hour because I'm, giving me buffer to work with. But
do you know if there's any server-side framework in Dart for SSE?
There is. So you can use this. I forgot the name again.
Shelf.
Shelf. So Shelf has you have to. It also has support for WebSockets and everything. Is you have to basically do some add-ons. But it's the same thing. It's a cascading kind of thing, right? You define when a connection comes. I want to check if it's HTTP, SSA. So you can also do that with that. But again, was not my best experience in my life. So that's why I didn't show that part of the code. I have it on my machine. If you want to see, we can have a talk later on. Actually, I have, let's see, 3, 6, I have 7 IDEs open here with everything that I could show. but I don't know how we're going to do on time, so I'm not showing you that, and at the end I maybe can give it a whirl of trying. I wanted to be prepared and not having to load the IDs, that's why. Alright, so WebSockets. Of course, this is not the official logo. All these solutions that we had up to this point were HTTP based, and this has support for, so it's backwards compatible with HTTP. It uses HTTP to establish the connection, but it's a little bit different, and we're going to cover this. So WebSocket, it's a computer protocol, a communication protocol, which is full duplex over a single TCP connection. And that only means you can talk on the same channel using the same TCP connection. You can talk both ways, right? It's not like the other ways, which are just half duplex. So again, WebSockets are compatible with HTTP. If you ever felt like you're never going to need this in your life after university, there you go. Hope you understand me. So WebSockets happen on the application layer, so up there on the 7th layer. And it has the dependency on the 4th layer, which is the TCP transport. Just put like this to make the life of your teacher worth, right? So hope he's happy now. And again, looking at support, you can see this is even better than SSE that we saw before. Has about 96% support. Wide, always Opera. I don't know. Is Opera still being developed? Because it's always red when I look for something here.
I think it's dead.
Yeah, right? So, yeah, it should go, because it's ruining my statistics. So this offers pretty good support, and the interesting thing, at least I found as a good full-stack developer, is it works over port 80, but it also has like a TLS encrypted connection over the 443, so you don't even need to learn new ports for it. Just use the same as you know. And the protocol is just WS for WebSockets, // whatever, and WSS when it's encrypted. So you would see that if you open the developer tools on your browser. So this compatibility I talked about is basically WebSocket makes a handshake. So it asks the server, like, hey, can we talk in web server-ish? And then if the server says yes, it upgrades. So it sends an HTTP upgrade header. That's the name of it. And if not, he will make the connection in HTTP over. So there's a fallback for that. So again, a little bit more formal. That's the idea. You have your HTTP upgrade there. A client initiates the handshake protocol. If the server says, hey, we can do this, then they will start this bidirectional messages part that I wrote there. And if not, he will respond accordingly, saying, hey, I don't understand what you're saying. Let's not do this. So you should handle this also on the client side, right? This is something to think about. It's another one of this. Like I promised, I'm going to say stuff that you should be thinking about, and that's one of them. One interesting thing is WebSockets are frame-based and not stream-based. If you ever open the developer tools, you would see a lot of stream-based stuff. And what is that stream-based? Basically says, like, if the server has to send you about 6 bytes of data, you're going to get 2 and then 3 and then 4, but you never know when it's finished. You're always receiving, it's a stream, right? Frame-based is no, he says, hey, I'm going to send you 8. If you get 6, you're still waiting for those last 2. Right? So it means that there's a little bit more control there. And again, with WebSockets, there's a lot of stuff that HTTP takes care for you, which is not taken care, so you have to take care of yourself. One of them is, for example, HTTP2, you can multiplex over different connections, and this is not going to happen on WebSockets. So if you want to do that, that's a thing to think about. Other thing that I saw a lot of people complaining that, especially nowadays when you're working on environments where you have a load balancer that takes care of these connections. If you start getting connections and everything into a server, and then at a point you realize, oh, damn it, I have to load balance this, you have to break those connections to make a reconnection, and it doesn't reconnect automatically. So the server would have to see, oh, it got disconnected, oh, let me reconnect it again to allow for this, right? If both of the sides are in your control, great. It's a little bit of work, but you can make it work. But if you're just taking care of the server, it's something that, is potentially a big problem. Then I wanted to give a couple examples of where WebSockets are being used, and I have to say this was kind of hard. And I can see already here that I ruined because I forgot to put animation into two logos. So these two logos are already there. But basically, this is one company is called N10.io, and they do high performance real-time integration. They have customers like NASCAR and HSBC, and they use WebSockets, and they were even one of the companies that started like the WebSocket. And Kaplan is a financial trading system. I know them actually because the last company I worked was in the financial sector, and that's how I know them. But you also have some stuff. I found this open source VNC client, and they actually use, everything is on HTML and JavaScript. They use WebSockets to make the connections there. Games are a good match for this, although I didn't find any big names that I can say, oh, they're definitely using WebSockets. I guess people don't want to say like, hey, yes, Call of Duty, this is my stack, and this is what I use, and this is how I program. They like to keep it under the wraps, right? And I also found a mention that Office uses a little bit of yeah, I see some laughs here. That Office uses a little bit of it, mostly for the synchronizing on Office 360 and everything. So again, how about Flutter? And I think WebSocket, when I first started looking at it, I thought, oh, this is quite new. There's probably no support, but I was quite surprised because there's even a cookbook for it right now. And in my understanding, if there's a developer cookbook page, this thing is already, in a certain level of acceptance. So I took a look. There are some libraries available. Again, these are 3 that I found. On Dart, the core, there are even like WebSockets supported there, and there's the object for WebSockets. So because this is on Cookbook, and because of the experiments I didn't match very well on a slide page, I decided to go with the example they give on the Cookbook, and that's using the WebSocket channel library. And this is how it would work. So you would have, this package provides you something which is called the IO WebSocket channel, which allows you to listen and send stuff for the server. So you create this object, connect to the server, and then you have to give the correct URL and port that you want there. So one-liner. And then you can use this channel to listen for the stream, right? And here, again, the example is using a stream builder and the channel stream there. But of course you can use anything else you want and can put this in a provider or anything else like that, right? After that, in any point in time, you can send stuff through this channel using the sync. So it's if you ever work with Block or anything similar, or any stream for that matter, you know this API. And eventually, when you're done with it, you should just close this channel so you don't keep this connection alive the whole time, right? So again, trying to fit everything in an example, I tried a complete-ish example. And basically what you would do, and the example here, what we're trying to do is just an echo server. And again, I have the code I programmed myself, an echo server too, in Dart this time too, but also in Java, in Spring Boot, and on Javelin. And I can talk about this experience in a bit. But the idea is simply, you create the channel on the widget, a stateful widget here in this case. And then on the state, you create on Stream Builder, and you say, hey, listen to what's being sent from this server, and render this on a text widget. Then there's also a method which you're going to put somewhere. When you press a button, you're going to call it and say, hey, if there's something in this text, just send it to the server, and that's it. When this is done, when I'm finished with this, just dispose of it. So what happens is you get something like this, right? You can write something, and when you send it, you get the same thing back, which is an echo server. It's not doing anything else. Server is receiving that and giving it back. And looking at only this is not very exciting, but when you have the logs for the back end too, I swear to God, is really exciting. I was having so much fun. My girlfriend has to ask, what's wrong with you? And I was like, oh, you don't understand. I wish. All right. So on the server side, as I said, this is a pretty easy example, right? And I found the server side, if you go a little bit further, it's not very straightforward. Because you're only dealing with messages. So there are some protocols available which are used, but I didn't like them, and I kind of created my own, where it was just like a message object. Inside there was the type of message, what kind of message. So I was saying like, okay, first message is a join message, then anytime I send. So you had to create this, and of course this is handled on the back end, which is a big switch statement saying like, oh, in case type is this, go this and do that. So it's not, if you're coming from a, I would say, classical server kind of thing, you know, REST endpoints and controllers and everything like that, it might feel a little bit cumbersome. It might feel too much work. But this is the thing. You want to do something a little bit more real-time, you're going to have to work for it. Maybe there are going to be some frameworks that are going to make this a little bit easier. But I'm also not a big fan of stuff like, you know, Spring Boot. I use it a lot, but I don't like this magic happening, which I don't know why. And why is this configured like this and stuff like that. So you have to be aware of this. And I also found it's very differently depending if I'm using Dart or if I was using Java, and even on Java if I was using Spring Boot or micro frameworks such as Javelin. The way that I handled this process and the stuff I get, it was different. Like on Spring Boot, you would get a certain method being called where you would register that would only happen on registration. There was another method only happen on close, and then everything else would come inside one method. On Dart, this was completely different. I had to declare stuff that I had to do, and in a certain way that I only get one kind of object, and I have to see which object is this? Is this a what's called connection, but is this a closing connection? Is this establishing connection? Is this just a single connection? So you have to kind of like test for the type of object. So I would say you just have to choose one and you know, go with it. Learn a little bit and do your framework. So you might be looking into some kind of, I'm going to say it vendor lock, but you know, it's not transmittable one-to-one to anything else. So any question on WebSockets here? Else I'm going to jump to WebRTC right away. No? Maybe? Is this a question or is it just a little?
No, I was very curious because you said they are so different, vendor lock, and you really have to think about whom in front of the other. And I was like, oh, maybe you can show us what you...
Sure. I can show, or what we can do is we can come back, and because I don't know how much time I'm in. I forgot to press start here.
You have 9 minutes.
9 minutes. All right. Okay, guys. It's time for wrapping. Okay, but afterwards you can take a. I can show you everything here. So WebRTC. Again, this is not going to be completely in-depth thing because this is also not a very straightforward topic, right? But the idea here is one of the last things was missing on web was allowing people to talk to each other as easy as just putting text on an input field. That was like the premise and the dream. So before that, you used to have, you know, install plugins and proprietary software that would allow, you know, Skype, install Skype first, so you could talk only through Skype and stuff like that. And people got together and decided, well, we need a better solution. Actually, a lot of it started from Google. They bought a company that used to have a lot of these codecs and make that open source and then create a consortium that created the rules for this. But basically, so RTC, sorry, stands for real-time communication. Keep using it, but maybe you don't know about it. The idea, it's allow you to talk directly to each other, right? So I call you and we talk directly, no need for server or anything. It's a lie, you still need servers, that's what we're gonna see. But the idea is most of the stuff is being directly, so no need for the server, which makes it good because you have less latency, which is perfect for audio and video and even data. It uses the UDP protocol, so that means dropping a couple of packages, it's okay. And that's even okay. I mean, everyone talked in a video call where there's some glitch, and it's not like you suddenly don't understand anymore what's being said, right? You still get the context. Yeah, sometimes I get it, yeah. Especially if I'm talking to Brazil at home and connection is awful. So again, can I use? Again, it's not bad, you know? Forget about Internet Explorer. You can see Edge is going to have on the next iteration of it, is going to have full support for it. Opera, again, ruining our stuff. And Chrome for Android also works. So actually there is, I did some tests and Chrome for Android worked pretty well. So, who's using it? Google Hangouts and Google Meet use it. All the interaction we have there, it's being done through WebRTC. We have Facebook using quite extensively on all their products. It's on Messenger, on Facebook Live, VR Chat, which is on Oculus. Workplace by Facebook, which honestly I didn't know, but it's something aimed more for companies, and Instagram Live video chat. So everything is based on WebRTC. Discord is using it, and I didn't know, but Amazon also has something. It's called Amazon Chime, and apparently these numbers are from 2017, was the best that I found. But they have something about 24.8 million minutes a month. Going through this WebRTC framework on there and stuff. It might be a little bit more now, I don't know. Then there was one app which I was kind of surprised. It's called House Party. Has anyone ever heard about it?
Yeah.
See, cool. You're a cool guy. Because apparently this is described as when your kid stopped using Snapchat or Snapchat's not cool anymore, he's gonna change to House Party.
No, it's just
And I was like,
group video
yeah, I'm old.
It's primarily focused on group video chats
All right.
with multiple people.
Yeah, and they have 20 million minutes a day in 2017. So it's you know, it's a lot of traffic. Then there's Pure 5, which has 1 billion connections a day. But connections, I mean, sometimes they're very short-lived. You try to connect, doesn't work. It counts. But you also have Twilio, which I guess most of people heard about, is also using. So these are a couple of examples. I could actually find, there's a lot of more stuff, a lot of more marketing happening around WebRTC than WebSockets. So it was a little bit easier to find this information, although maybe not up to date. So how does it work? The server is still needed for client discovery, right? This is the most important thing. So it's not completely serverless in not the serverless sense. The idea is the server is still needed to exchange metadata. Metadata is stuff like media metadata, like which codecs are we using, which settings are for them, bandwidth, media type, key data for a secure connection, host IP address, that's the biggest thing. And this is what we're going to cover a lot. So you have to know where is the person you want to talk to, right? Or else how you're going to connect here. So that's why the server is the biggest thing there. So suppose these two want to talk to each other. And I know what you're thinking, you're like, Flavio could put some effort there, look like this guy's talking to himself. And to that I say, I don't know what you're talking about. It's clearly a different person, right? So, person A, let's call him person A, and little mustache man here. He wants to talk to him, so he makes use of a server, a signaling server. And basically he asks for the server, hey, I'd like to talk to B. The B has to be at some point, you know, logged into the server, of course. Just like you would see someone is online on your friends list. That's the idea. So he goes, hey, I want to talk to Mustache Man. And he goes like, hey, Mustachio, this guy wants to talk to you. Are you okay with this? And the guy goes like, all right, I'm good. You can give him my data. And he gives him data, and boom, they're talking. So the media up to this point, they can talk directly to each other and don't need a signaling server anymore. So again, signaling server is just for the metadata, and all data, media, and data streaming is directly peer-to-peer. But this is the real. This is the ideal world. You know, like those where chickens are round spherical things with no friction in the ground. Remember these things in physics? That's the world we're talking about. So that doesn't work. The problem is, not everyone has a unique address, right? Not everyone has a unique IP. You're usually behind a NAT, a firewall, where you have a subnet inside. So this is more of what the real world looks like. You're in some kind behind of some layers of network address translation, right? NAT, or have some antivirus or whatever. So to circumvent that, WebRTC uses something which is called the ICE protocol. The ICE stands for Interactive Connectivity Establishment Framework. And it tries to overcome exactly these problems of being behind a firewall and having like an internal IP and port which is not reachable from the outside. So the first thing it will try to do is try to connect with the address you got from the signaling server, which will fail most of the time. So it resorts to something which is called a stun. And stun stands for Session Traversal Utilities for NAT. I had to write these things down because I can't memorize these. The idea is they will get the address of the person, the correct address, so the internet known address, through these stun servers. So they have a chat and they say, oh, all right, inside your IP 10.10.0.1, but outside your 192.168.2.1, right? So they will know that this is the address, and when they see some incoming request to 10.10, they will know, oh no, he means actually 192, and then do the routing thing. So that's allowed the media, again, to be taught because he knows the address it should go. This apparently works 86% of the times, according to statistics on webrtcstats.com. There's a website for that. And I mean, this is great, but how about the other 14%, right? There's still problems there. And for that case, we use something else, which is called turn. Turn is called Traversal Using Relay NAT. And that's another server, which is going to take care of, again, you have to register it and kind of talk to it, but this is going to take care of transmitting the media there. So again, you're starting to have those jumps again, right? So it's not really serverless as it's said or advertised, but it's pretty good. Turn servers have to be a little bit beefier because they have actually media being transported there, so the bandwidth is a bit bigger. But stun servers are usually very, very small. It's just basically an address translation, right? So a matching in a table. So what they usually have is these two combined. Like a turn server can be a stun server at the same time. They combine these two. But both of them are not using for signaling. Signaling is just a cool guy up there, right? You have to remember that. And this might sound, so all these slides explaining this was not in my presentation. But what happened, I was trying to make a demo, and it didn't work. And I kept reading about it, and the problem was exactly that it was not finding my address. And I had to use a stun server, and that wasn't doing it. Then I had to use a turn server, and that actually made a difference. So I thought, maybe you guys didn't learn anything I just said, but now you know if it's not working, well, you should take a look at it, right? So in Flutter, the support there, I found this one library, which you can, open source, which you can use, it works, but is one library, right? You have a lot of commercial plugins, stuff like, yeah, you use this plugin to connect to our services and we offer the whole turn stuns and you pay just whatever, I don't know how much for minutes per month, you know, the usual thing. So I like to, you know, whenever I'm doing these talks, I don't want to do a marketing pitch for any company. I want to actually say something you can do yourself. So using this first Flutter WebRTC, I've tried hacking stuff together. It didn't work, so I used the demo they provide. Started fiddling around because it also didn't work, and this is what eventually I got. So this is me. My setup is my tablet there behind my computer running Flutter. Is talking to my phone, right? And this is a photo, a screenshot of my phone. So you can see both are being connected and through the internet. So I'm doing a whole loop through the internet here, and you can use this to do whatever you want and have some chat with friends. I tested around even at the office. It works quite well. Don't be too close, so you start getting that signaling and amplifying thing, which annoys everyone in the office, except you, because you're thinking school. So I would say my advice for you guys, if you want to play with this, is go to this, use this library that I mentioned, and they have a demo product. Start with that. And have a feel for how it works. But basically, if you say like, okay, I understand how it works, but I want to integrate this on mine, first, make sure that works with your infrastructure, because that's the biggest problem, to see if this whole turn stun thing is working, so your test app is actually connecting to each other before you start changing the code and thinking like, oh, I did a mistake somewhere. Right? So once you have that, you can start to play around. And I tried to create like an overview, like the 5 most important steps here, but it was kind of hard to do with this. I would say the first thing you have to do is initialize the video renderers. And that's both for your side and the incoming stream from the other side. You connect to the signaling server, which uses WebSockets, which is kind of cool because we just saw it. At least I found it cool. My girlfriend didn't find it. No, I'm kidding, because she's going to watch this. Okay. And then afterward, you create the peer-to-peer connections here, and you receive the streams. So you start actually using that and rendering on your screen. You can talk to the person, and eventually you hang up. And this whole thing, all these steps are signaling to, like, you have to send the signals of, hey, I want to start a conversation to the server, and then he sends like, oh, this guy wants to talk before you start connecting. So the signaling server is also in the midst there. Right? I did a bit of things to consider here. It's still relatively highly supported in Flutter. There's this one library which is mature enough to use, so keep that in mind. The server code is the biggest thing, and I'm not kidding here. It's really complicated to understand. I mean, for me, maybe you guys are, well, probably you guys are a lot better than I am. But it's not a straightforward kind of thing. It's not something you get, oh, I have an hour, let's understand WebRTC and how it goes, right? You need to focus a little bit. You have to think about the signaling. You have to think about this whole ICE stun and turn thing. And the client-side code is also not trivial. There's also something to be done there. So if you want to do this, I highly recommend, but be aware of this. It's going to be some work, right? Don't expect to get stuff done in 2 hours out of the box and stuff like that. So I talked too much. What we talked about some solutions for one-way communication that might be the solution for you. Always think if that's enough for you, it's easier. You avoid a lot of headache instead of starting to use WebSockets and WebRTC. And then we went over the whole two-way communication and showed, which opens a lot of possibilities, but there's some work to it. I also did a little comparison table here and put basically the stuff I found or I spoke about here, which is the number of connections. I found some guy did some experiments and found that 256 was the limit on WebRTC. That means you can have 256 streams in one conversation. So you can have a chat with 255 other people. I didn't try. I don't know that many people. Load balancing and proxying is whenever it's standard, it means it's easy to implement. Non-standard means it's a bit more cumbersome. Browser support is basically what we saw. And this drop client connection, reconnection handling is also stuff you can see it's not out of the box in most of these cases, like the others, right? So without further ado, any questions to these two topics or anything that I might help?
You said that a lot of you, so when people use WebSockets, they should use as server sent events. Could you give examples?
Well, simple chats. So whenever I looked into like applications of WebSockets and how you can use it, a chat application is usually the go-to example, right? Yeah. If it's just a one page or like one room where everyone connects and you don't need WebSockets for that. You can simply like publish your how do you say? Your message to a certain ID, and the server realizes, oh, who's subscribing to this ID and just sends that, right? You don't need to have a double way open socket the whole time with it. Like you can, of course it works, that's why people use it, but it's maybe an overkill. If you're starting to do also server side and all this thing about like, Kubernetes and having that, HTTP is way easier to deal with than WebSockets. So this is one example. But also I've seen WebSockets being used for like to-do apps and stuff like that, which is...
Isn't Firebase also using WebSockets, I think? So
no. I didn't find the information. They have their own solution kind of thing as far as I understood.
They use gRPC, which is the binary protocol. But
which is the same
also,
they use on Docs, isn't it?
Docs.
So Google Docs. So there's a cool talk about Google Docs and how they actually solve it, because at first I also thought WebSockets, but apparently they had their own solution also to allow this redo and undo kind of thing.
Yeah.
But examples, I mean, of stuff that you would use and you have to kind of use WebSockets are games. It's the biggest thing. Yeah, I've seen a lot in like financial software
Yeah.
because they need this stream of data coming in and they have to send it. Instead of opening channels all the time, it's way more efficient to have one channel open where they have this two-way communication with the server. So maybe if it's a little bit more performance-based.
Okay.
But again, there's the cost of all of that, right?
On the previous slide, you had the comparison between SSE and WebSockets,
Yep.
and the load balancing in WebSockets is non-standard, but SSE is standard. Can you explain what exactly is the difference between load balancing with SSE and WebSockets?
Yeah, so the SSE works completely on the HTTP thing, right? So it comes, it's what I said, I'm not going too much in detail because I probably will say something incorrect, that's why. It's not because I'm saving you from hearing that. So a lot of the stuff that HTTP has already takes care of the whole, so there is a certain way of, you're connected to something, and if it breaks, it will try to connect automatically, and this is what it means with load balancing and proxying, because if you need to load balancing, you might have to sever that connection to be able to move to the other place, right? In WebSockets, they recognize that a drop client happened, but they don't reconnect automatically like HTTP protocol would offer to you. That's one
It's
example.
only the client side. Because with SSE, you would still have to care about moving the connection to another server.
Sure, I mean, the whole process is still the same, but what you would say, oh, this is what I have to do to move these, doesn't apply necessarily to WebSockets. You have to do some other juggling of the artifacts and connections, and maybe save these connections first and then disconnect and then move and then remember who it was to connect and this kind of stuff, which HTTP, maybe I would say most of the tools already have something out of the box. Like Kubernetes, it takes care of load balancing. You don't think about the client having to reconnect to stuff like that.
Does SSC also use then heartbeats or stuff like that? For example, AWS load balancer normally disconnects you after 60 seconds if you
I don't know.
send data and stuff like that.
Because good question. I don't know. I would say no, there's no need for it. But again, it has a TCP connection being alive, so it has to have some kind of, the are you still there kind of situation. But I didn't look into it. That's a good point. Maybe we can take a look afterward. Again, just to another point, this do you really need WebSockets? There's a great article about this. And I put this on the comments here, so it's going to be available for you guys to click around later on. All right, just because of time, I would say thank you very much. And if you need to contact me, you know where to find me. So thanks again.
Um,
And I can show